So as always, these videos slowly build into a spot. So the next thing that we are going to do is we are going to do calculations with strong acids and bases. And then the next video, we're going to mix acids and bases together. So in this video, we are going to be simply calculating POH or pH or something along those lines, which results when 0.450 grams of hydrochloric or hydrogen chloride are added to 200 mils of water to become hydrochloric acid. So the thing that we're going to look at here is that when you put hydrogen chloride in some form in water, so I don't really need to include states here because we don't actually know what form the hydrogen chloride is in, is that it is going to ionize to hydronium and chloride ions. And again, if you wanted to do this without the water involved, it would just be going to hydrogen and chloride. And what they want to find out is what is the pOH of this resulting mixture, which maybe we would want to find hydrogen ion concentration or hydronium ion concentration so that we could then find pH and then we could find pOH. But to get there, we have to know the concentration of hydrogen chloride that we're starting with. Now we have 0.45 grams that we are adding to 200 milliliters of water. So let's find the concentration of hydrogen chloride that we're adding. So the first thing we're going to start with is that to find the concentration, it's going to want to be moles per liter. Right now we're in grams per, and I would just change that to liters. So I would put it as 0.2 liters. So right now we are in grams of hydrogen chloride per liter, and we want to change that to moles per liter. So I'm going to say that put the mole on the top, right? I want to go from grams to moles, so grams are going to go on the bottom, moles are going to be on the top. It's going to be 1 mole, and I have to find out how much 1 mole of hydrogen chloride would weigh. So hydrogen is 1.008 grams per mole. Chloride is 35.45 grams per mole. So the molar mass of hydrogen chloride is 36.458. So the concentration of my original solution is 0.45 divided by 0.2 divided by 36.458, which gives me 0.0. Now let's keep track of sig figs. So we're going to do 3 sig figs. So 0.0617 ... moles per liter. Now this is moles per liter of hydrogen chloride. But when we dissociate, we're going to dissociate into a 1-to-1 ratio, which all the strong acids will. All strong acids donate 1 hydrogen at a time. So the concentration of your original species will be the concentration of your hydronium or your hydrogen ion. So in this case, the concentration of hydronium will also be that 0.0617 ... molarity. Now that's not what they asked me for. They wanted the resulting pOH of this mixture, of this solution. So the next thing I'm going to do is I'm going to find pH. So pH is equal to negative log of the concentration of hydronium. So it's going to be the negative log of 0.0617 ... because I have not rounded yet. So I'm going to go negative log of my answer. And I get, keeping track of sig figs, so I was at 3 sig figs, so I'm going to do 3 decimal places, 0.209 ... So this is actually going to round to 1.210 if I was giving that as a final answer, but I now need to calculate pOH. My pOH is going to be that 14 minus the pH, so it's going to be 14 minus the 1.209 ... So in my calculator, I'm just going to hit 14 minus the answer, and I get 12.790. And again, just keeping in mind that idea of acidic and basic, I like to look at pH. Obviously, this was a strong acid, so my pH is quite low, and this is a very acidic solution. All right, let's switch to a basic solution. Let's start with calcium hydroxide. So this question is a little bit different. This says what mass of calcium hydroxide must be added to make 500 milliliters of a solution with a pH of 12.5. Well, we know that calcium hydroxide would dissociate in water to form what? Well, we know that it's going to form hydroxides, okay? And so if we were to write the dissociation of calcium hydroxide and water, actually, you know what? We don't need to include the water. I was confusing myself there because if you're doing a base that doesn't have a hydroxide, you need to include water because that's how you get the hydroxide to appear. Whereas when you're dissociating a metal hydroxide, don't include the water. That is actually, I'm not going to redo this video because that's an important lesson, is that anytime you're doing a base in water, make sure, or a base without hydroxide, make sure you include water so a hydroxide is a product. Whereas when you're doing it of a metal hydroxide, it's going to dissociate into calcium and hydroxide. Okay, so that we don't have to include water. Okay, all right, so now what are we going to do? Well, we want to somehow get to the mass of calcium hydroxide, and what they've given us is the pH. Now, from pH, we could find pOH, which would then allow us to find the hydroxide ion concentration. So let's start with that. If we want to find the pOH, we're going to do 14 minus the pH. So we're going to do 14 minus the 12.5, which will give us a pOH of 14 minus 12.5 is 1.50, maintaining precision. And then from there, we're going to find the hydroxide ion concentration. So hydroxide ion concentration is always 10 to the negative pOH. So it's going to be 10 to the negative 1.50. So 10 to the negative 1.5, which is going to give us 0.03. What are we doing here? So we've got 2 decimal places in my pOH. So I'm going to do 2 sig figs, so 3.1 ... because of course it would actually round to 0.032, but I'm just going to maintain my precision here. And then that's going to be the concentration of hydroxide. So the concentration of hydroxide is that 0.031 molarity. What I want to find is the concentration of calcium hydroxide, so then I can work that towards mass. It's in a 1:2 ratio, so it's actually going to be half of that concentration. Now you can show that as a molar ratio if you want to, or I just go that it's in a 2:1 ratio, so I need to divide it by 2. So I'm going to take that answer, divide by 2. I'm now at 0.015 ... And now where do I want to go? Well, I'm at 0.015 ... moles per liter of the calcium hydroxide. I want to work this back to mass. Oh, stoichiometry never leaves us, hey? So now let's go from moles to grams. So 1 mole of calcium hydroxide weighs how much? I'm going to store this answer I have in my calculator right now. Okay, so I can clear it. So let's look up calcium. There is my... One sec, I've lost my formula sheets. All right, I had to go get a new one. So calcium. Calcium, if we look it up on our chart, is 40.08. And then we have 2 oxygens at 16 grams per mole of each, and then 2 hydrogens at 1.008 each. So then the molar mass of calcium hydroxide is 74.096 grams per mole. So now I've converted from moles per liter to grams per liter, and then lastly I want just grams. So then I'm just going to multiply by the volume. So the 500 milliliters in liters would be 0.5000 liters. All right, so plugging this all into my calculator, I'm going to hit my recall A. I'm going to multiply that by 74.096, and then I'm going to multiply that by 0.5, and I end up with the mass, which where were we at? We were at 2 sig figs. So the mass would be 0.59 grams of calcium hydroxide. All right, hopefully that felt pretty smooth for you. And that is the end of 4.12.